will be the exam, physics 1101, exam 4, review on chapters 10 and 11. So this includes fluids and oscillation waves. So I'm just going to go through the sections. I have the lectures on that, so I'll just talk about the sections here. Part as far as fluids, we have density, which is mass over volume for section 10.2. I'm not going to go through any of the details in that, other than the fact that we have units are kilograms per meter cubed or grams per cubic centimeter. Where water, H2O, which we'll be comparing all these, is either 1,000 kilograms per meter cubed or 1 gram per cubic centimeter. Okay? That's actually where a lot of the metric system came from as far as some of these units. If you need any other densities, either we provided for you in the test, but generally, when we talk about specific gravity, the concept of specific gravity, it's relative to water as a number. So that's section 10.2. 10.3, we then get into the concept of pressure. P, which is force over area. So this is a weight over an area. So weight over an area, right? And this will be in newtons per meter squared. And since you're dealing a lot of time with the atmosphere, 1 atmosphere is 101,000 newtons per meter squared, or the unit Pascal. So 101,000 PA, Pascal. All right, and then we get into density. So that's for dense. So that's 1 atmosphere. For water, pressure goes as rho GH, where rho is the density, and for water, 1 atmosphere is approximately 10 meters in depth. All right, and the fact that it's incompressible. So every 10 meters you go down, you add 1 atmosphere of pressure. As far as that's concerned, it has nothing to do with how spread out it is. It matters about how deep the liquid or fluid is you're dealing with. So that's section 10.3. Section 10.5, we did a little bit with Pascal's principle. So we'll go up here. So look up Pascal's principle again. Is 10.5. And that has to do with, we have 2 liquids, area 1, area 2, force 1, force 2, and the fact that the pressure is equal on both sides. So pressure in, pressure out. So relating that to force over area gives you the relationship between force and area on that. So that is section 10.5. I've got section 10.3. There's nothing in section 10.4 we're going to do as far as pressure gauges and such. I'll leave that up for a minute. Okay. Nothing in barometers. Oh yeah, our 10.7. This is lab. I can't remember what lab anymore. There's a lab on Archimedes principle. Well, that was lab 10. So So 10.7 is buoyancy and Archimedes principle. All right, so this is buoyancy and Archimedes principle. And what that involves is the fact that if we have an object in water, right, its weight of gravity pulls it down, but there's a buoyancy weight pushing it up. And based on the density, from this you get the density. So the weight in air, the weight in the water is reduced based on the amount of volume displaced by this container. And as we go, we look at density of the object, Archimedes principle, H2O would be the weight in air divided by the weight in air minus the weight right. So, and the buoyant force is W minus W. So that's the weight in air, and that's the weight in the water. So the closer they are, meaning the denser it is, the higher this is going to be. So that's Archimedes' principle as far as that's concerned. And that's the buoyant force. So that's the weight in air, the weight in the water. So that's that. And then for an object that's submerged, will be make sure I got the right formula. Right. Density of the object divided by density of H2O. So this is the volume displaced. So that'll be the dense. So the volume displaced. So say if it's half submerged, so it's the actual volume. Oh, no, backwards. All right, so if only half of it is submerged, that's the total volume. In this case, 50%, then the density of the object would be 0.5. The deeper it sinks, closer it is to 1. If it actually used to float right at the surface, it would be 1. So that is Archimedes' principle related to an object that floats. And we've talked about that before already, as far as earlier. Okay. Section 10.8. So 10.8 is continuity equation. All right. A1V1 equals A2V2, where we have area 1, area 2, area 1, V1 coming in, V2 coming out, and these two are equal in that regards. So that's the continuity equation. And then related to this, we have Bernoulli's equation. So 10.9, Bernoulli's equation. And this is P1 plus 1/2 rho V1 squared is P2 plus 1/2 rho V2 squared. Basically, this has to do with airplane wing. So pressure on the bottom, P1. Well, let's keep it consistent. Yeah, P1 on the bottom. Air goes past there. Has to go fast on the other side, P2. So if it has to go faster, P1 is going to be greater than P2, and that will give it lift. So at V2 is greater than V1. So it has to go faster. That's Bernoulli's equation, Bernoulli's principle, and I did some examples with the quiz, with the lecture related to that. So there's your continuity equation for section 10.8. There's your Bernoulli's principle for an equation for section 10.9. Okay. And that is basically it for chapter 10. So that's chapter 10. We're not doing the rest of the sections. Even though they're relevant, I'm not going to be testing on those. So I'm going to go on to chapter 11, which again is a lot of it we've already done. So I'm not going to spend a whole lot of time on that. So for chapter 11, in that case, we have 11.1, a spring, spring constant, Hooke's law, F equals Kx, minus Kx, you should say, where this is the spring constant. And the units of newtons per meter. And for a spring, we're talking about oscillations. A spring or pendulum oscillates. We talked about, we have the frequency, which is a reciprocal of the period. So it's the frequency in hertz. This is the period in seconds. So that's the first part there. For a spring, all right, section 11.3, then the period for a spring, the period is 2 pi m over k. M is the mass on the spring, k is the spring constant. Those are the only two factors that determine the period. The amplitude, is that, but it does not affect how hot, how fast, how fast is pulling, has nothing to do with it. It's just those are the two factors for a spring. Okay. So that's section 11.3. For a pendulum, right? So for pendulum, 11.4. All right, the period is similar formula, L, where G is 9.8 meters per second squared, and L is the length of the pendulum. Again, those are the only two factors to determine the period of a pendulum is the length and the acceleration of gravity of it. All right, so that's section 11.4. Again, there isn't a whole lot to either one of these chapters, so pay attention as far as that's concerned. We're not covering 11.5, 11.6. Now we do have 11.7. This we get into later is 11.7. The speed of a wave is given by the frequency times the wavelength of the wave. And we have two types of wave, transverse and compression, or longitudinal waves. So in the book on 11.8, they talk about compression waves, transverse waves, which can do in solids, and compression waves, which can go to solids, liquids, and gases. So that's a little bit, I'm not going to get into earthquakes right now as far as that's concerned, but that's how you can tell the difference of an earthquake and how we know about the interior of the earth is that. So that is, yeah, and then we have the last part, 11.11, is on superposition. Or adding of waves. And then the final section was on standing waves and resonance. So 11.12 was standing waves. Resonance. All right, for this test, this will be primarily lab 11, and then for the next test on chapter 12, that'll be lab 12, which is the final lab for the semester. And I've talked about that separate. So that's the exam for that. There will be 31 multiple choice questions. And for this test, I'm not going to have any short answer questions. Everything will be multiple choice. You get one attempt, you get 110 minutes to do it. It'll open on November 14th and then close in the evening of November 18th. So that'll be exam 4. And again, we'll be dropping the lowest exam score. So at that point, after that's closed, I'll be actually including exam 5 as a dropped exam, so you can see what your scores will be. Doesn't mean I'm literally dropping that, but that would be what would happen if you missed exam 5. All right, so that is the exam for chapters 11, 10, and 11. Thank you.